Alrighty, I'm going to go over the remainder and factor theorems again as a little refresher in terms of what we did today. As a reminder, the remainder theorem is basically whenever we have x minus c, the remainder is f of c. And then the factor theorem, if f of x is divided by x minus c, then the factor theorem basically states that x minus c is a factor if and only if f of c is equal to 0. Looking at number 3, I have f of x is equal to kx cubed plus 14x squared plus 23x plus 14, where k is a constant and x plus 2 is a factor, and we want to find the value of k. In class, I showed you guys two ways. The first way was the synthetic division way, which is probably the easiest way because your function isn't that bad. It's not big. It's not a giant. So you know that you could use synthetic division, where I have k, 14, 23, and 14. I want to find out what k is, and I know that x plus 2 is a factor. Since x plus 2 is a factor, I know that my remainder has to be 0, and essentially what we're going to do now is work backwards to find my k value. So working backwards, if I have a remainder of 0, this right here needs to be a 14, a negative 14. And if this is a negative 14, then this right here has to be a 7 because negative 2 times 7 gives us negative 14. Well, to get 7, I need to subtract 16. So 16 is right there. Well, to get 16 or negative 16, I need an 8 right here. And if I have an 8 right here, then I need a negative 6 right here. And then to get a negative 6 right here, I need a 3, which means that your k value is equal to 3. Remember that your quiz and your test is going to be calculator inactive, meaning this might be the easier route if you're not strong with algebra. I'm going to show you the other way where we use the factor theorem and the remainder theorem, meaning that I want to find out what f of negative 2 is, which is 0. Same thing here. So I'm going to substitute in negative 2 for x. And then evaluate. Notice how here your evaluating might be a little bit messy if you aren't that strong in algebra and mental math, especially since this is calculator inactive. Once you do all of this mess, you are going to see that k is going to equal 3. There are pros and cons for each method. Pros for this one right here using synthetic is if and only if you have an easy function that you're working with like this. Now, if you have something like, what's the remainder of 2x to the 99 minus 5x to the 102 plus x to the 47 minus 3 by x minus 1, well, you know you're just plugging in f of 1 to find out what the remainder is, or to find the k value if you wanted to find the k value. So use synthetic if you have an easy function, and then use the little theorem right here if you have a large function that you can't really use synthetic with. Okay, so for number 5, I'm going to use synthetic 2 times, and there's going to be a reason why I use it 2 times. The first time, I'm going to use it because I have x minus 2, and the remainder is 3. So I know that I have 2 inside my little house. I'm going to bring down my coefficients, and I know that my remainder is 3 right here. So once again, I'm just working backwards. And then I'm also working forwards until I hit that k value, which is really what I want. So going forwards, starting at the 5, I have 10, which then turns into a negative 1. 2 times -1 is a -2. Can't really do anything else now, so I'm working backwards. Well, to get a 3, I need a -16. And then to get a -16, I need a -8. So now I need to think, k minus 2 is equal to -8. What is k? Well, it's -6. Yay. Given that k is -6, I want to find the remainder of, or not the remainder, I want to find f of 1, f of -1. Well, to find f of -1, that's just me finding the remainder of this lovely function that I just found, except instead of k, I'm using -6. Since we just found out that if f of x is divided by x minus 2 and the remainder is 3, that means k is -6. Do it again using synthetic, and you're going to see that your remainder is going to be 9. Now, if you did it the other way, where you substituted in a -1, that's also fine. As long as you are skilled in algebra, then you're going to get the same thing. Same thing with number 6. It tells us that I have a double root at 1. Essentially, I have a multiplicity at 1. So I'm going to use synthetic division 2 times, given that f of x has a double root at 1. Meaning, my remainder is 0. There's no k value here, so you're just working to find your other 2 roots using synthetic division. So you could see that I have 165 -12 as my first part. And then you're going to realize, hey, do I really need that other 1? Oops, that should be a 3. And you're going to realize pretty quickly that you can't really factor this using grouping or using any other method. So we're going to cry for like 2 seconds and then use the double root of 1 that I've told you to do so that you can factor easily. I have another 0 as a remainder, which makes sense because it says that I have a double root at 1. So I have x squared plus 7x plus 12 as my quotient. I could factor that easily because that's just x plus 3, x plus 4. So my roots here are -3, -4, and then you have 1 with a multiplicity of 2 based off of what my original statement was for number 6. Okay, so 7 and 8 are going to be warm-up problems for Wednesday. Hopefully, if you're watching this and you're not my kid, you could do this on your own. If you have any questions, email me, and let's make sure that we ace the quiz on Friday.